Hello everyone, I am Chetan from Sri Venkateshwara College of Engineering from Bangalore. The subject is computer networks, and I am going to explain the topic an improved transport layer protocol for wireless sensor and networks. Abstract. Wireless sensors networks are kind of communication networks having independent sensor nodes that from multi-hop and HOC networks to transfer data. In the first few years, various transport control protocol in wireless sensors networks have been developed and proposed in the literature. In this paper, we have analyzing the pump slowly, fetch quickly protocol and present an improved transport layer protocol for wireless sensors networks. The improved protocol have been analyzed based on the various factors such as average latency and average error tolerance, and it is found that the proposed protocol is better than the PSFQ in terms of these factors. Introduction. Wireless sensors networks is a self-organized distributed system consists of one or more base stations, which are usually called skins and tens and thousands of sensors nodes sprinkled in a physical area. Interacted of information sensors through the sensors, computations on that wireless communications making the sensor node able to gather physical data, process the data to be obtained information and reports to skins and can sensors nodes for more information have several categorized features. The major focus in this paper is on design of transport layer protocol for WSNS transport layer protocols are used to and reduce the packet loss of provides fairness is bandwidth allocated and due to the guarantee end-to-end reliability. However, UHP and TCP transport protocols, which are currently used for the internet, cannot be directly implemented for WSNF. For example, UDP does not provide a delivered that is often needed for many census applications, nor does it offer flow and control that can be lead the packet loss and unnecessary energy consumption. Related work. For WSNF, various transport layer protocols have been designed to address the various issues such as conjunction, control, reliability, or both. A brief summary of related protocols is provided in a section. Garuda is a reliable downstream data delivery transport protocol. For WSNF, it addresses the problem of reliable data from the sync on the sensors. It designed in a loss recover core infrastructure and a two-stage NAC based recovery process and inspired from pipe flow method and provides a hope by hope to make sure all the segments can be received by the sync with 100% reliability. Analysis of PSFQ protocol. PSFQ is a hope by hope downstream transport protocol which is reliable, scalability, and robust. It is used in NAC based loss detection and notification and a local retracement for loss recovery, and it is basically designed for retaking reprogramming application which requires 100% packet reliability in downstream directions. It consists of three operations: pump, fetch, and report operations. The pump operations control the rate at which data packets are passed into the networks. The fetch operation requests as retransmissions of the lost packet from the neighboring nodes. Latency. The report operation provides a feedback status to the users. This way, it provides 100% packet reliability. Message transmission. The pump operation controls the injection of packets into the network. These operations is important in controlling the timely distributed of code segment to all the sensor nodes and providing basic flow control so the reprogramming operation does not obstruct the regular operations of the sensors networks. For doing so, proper and scheduling is requirement for data forwarding. PSFQ adopts a simple scheduling scheme which uses the two timers Tmax and Tminimum. The important task of PSFQ is to recover the lost packets very quickly among immediately neighboring nodes within a controllable time frame. For that, it is needed to provide a time buffer for time minimum gives an opportunity to a node to recovery and missing segment before the next segment comes from in unstreaming neighboring since a node must wait at last before towards to forwarding a pocket as a part of pump operation. Local loss recovery. Sensor node starts and the operation to the local loss recovery. It started when a sequence number of gap in a files, fragments in detecting, channel impairments such as fading connections and also a correlated in a time. And as a result, loss of number of conjunctions data packets occurs instead of single packet loss. Therefore, uses of concept of loss aggregations whenever the loss is detected. And sensors node usually have more than one neighbor in a dense network. PSFQ allows different segments of the loss window to recovering from the different neighbors. And shortcomings of PSFQ. And firstly, PSFQ does in a sequence of forwarding of data packets. For example, in an intermediate node running transport layer protocol does not have any data packets to and also the data packets from 3 up to the last data packets. Then this node will not forward any of the data packet to the next sensor node. In the same manner, other nodes also remains until they get in a sequence data packet. So this increases the time at which last data packet will reach to the target node. Secondly, there are some drawbacks into the pump and repair operations in PSFQ. Whenever in sequences data packets arrives, it waits a random time between the time minimum and time maximum for forwarding the data packet node. Does this waiting by the setting a scheduling. Improving transport protocol out of order providing. Otherwise, the node will store the data packets into the data cache and scheduling into the forward into a head. Comparison of average delivery ratio of PSFQ as a function of network size. Conclusion. We have initially presented various protocols available for transport layer in a wireless census networks. After that, we have presented an overview of PSFQ protocol. We provide some alternatives to improve the PSFQ's efficiency. We have also shown the performance of analyzing the of, original PSFQ and improves of PSFQ, and it has been shown that the improved protocol works better than the original PSFQ in terms of error and tolerance and average latency. We have evaluated both the PSFQ and improved PSFQ using simulations, and we found that improved PSFQ has good error tolerance and delivery latency. Thank you.